By this point, you should have already done the reading for the lecture for the first week. You should have gone through all of the lecture notes, the videos that I put up before, kind of walking through the theory. And then this last part here is the practice problems. And so you're going to kind of work out by hand. In this case, it's the standard deviation. So we'll go through, there's two questions here on the thing you download. There's two problems, practice problem one. We're going to go through that together. And there's this little thing here. And then it says practice problem two with a different set of numbers. And then you do these by yourself. And then you save it and upload it to Blackboard, and you get participation points. So it's not graded, but you get points for participating and completing the assignment. So basically, I'm going to just show you exactly how to do it, and I recommend following along with you. So download this template and just kind of follow along. So do the math yourself. Pause it if you need to, and get comfortable with the process. Because on the bottom one, I'm not going to do that with you. I'll have to do that looking back over here since you've already done it with us together on the video. So here we're going to calculate the standard deviation of this distribution. So 7, 3, 5, 2, 4, 6. There's only 6 numbers. So it's a little simpler than if we had more numbers, but it's still a bit of a process. Here's the formula for calculating the standard deviation. S stands for standard deviation and equals the square root. So you get all the answer, everything under here, and then take the square root of that. That's what that means. This is a sigma, which means the sum. X minus the mean squared. So for each of the x's, that's each of the values, individual values, you subtract the mean, we know to do that, right, of all of them, and then square it. And you get all those added up, and then divide by n minus 1. So n is the sample size, which is 6, minus 1 would be 5. So you get all that, divide by 5, and then get all that, and take the square root. That's really all there is to it. Finding the standard deviation is actually a lot of fun. So if there's nothing on TV, you could do it on your own a little bit later on. So first step is going to be to calculate the mean of the distribution. So to do that, you add up all the values and divide by the number of values. So I'm going to show you how to use the Windows calculator. I have it shortcutted. I actually have it here, and I have it here, and there's also a button on my keyboard. But if you don't have it shortcutted like that, to get to it, you go to the Start button, and then to Programs, and then to Accessories. And just one on the top, and that would open up like that. If it's the first time you use it, it's actually going to look like this, but we need some of the other functions, and so to do that, we change the view from standard to scientific, and now we have things like the parentheses and some other cool functions. So that's how you get this calculator pulled up on the screen. If you want to shortcut it yourself, you would just go back and find it the way I just showed you. So Programs, Accessories, Calculator. And if you right click on it, you could put Pin to Taskbar or Pin to Start Menu, and which would put it either here or here, so you could find it faster. Anyway, we want to find the mean, so we're going to add all of these up and then divide by 6. A lot of people think that you have to click the buttons with the mouse, like 7 plus 7 equals, which you can, but you can actually use the numbers on the keyboard, which I do. It's a little bit faster. So I'll kind of show it to you both ways. So over here, we want to take the sum of all of the values and divide by n. So we got to add all these up for starters. So 7 plus 3 plus 5 plus 2 plus 4 plus 6 is 27. Right, so that is the sum of all the values. And we're going to divide by n. Well, n is 6. So we go to 27 and we divide by 6, and that gives us 4.5. And that goes right here. So I'm using this, I made this template. It's copyrighted, Robert Crosby 2013. This template to help you kind of follow along to make it a little less daunting. So we'll just fill in the values as we go. Just do the same thing on yours, and hopefully it won't seem too bad. So that's our mean, 4.5. All right, very good. So here, this part of the equation means to sum all of the differences squared, or sum of squared. So the original value, we'll put the original values right here. So we had 3 Got this backwards tonight. 7, 3, 5, 2, 4, 6. There's our original values, same as here. And then the mean we just figured out was 4.5. So I put all that in here. 4.5, 4.5, 4.5. Okay. So the original value, we have the mean. We want to find the difference between the original value and the mean. Then we're going to square that difference and add them up. The sum of squares. We'll use that term. A lot of different formulas use the sum of squares. We'll see that in a couple weeks with an ANOVA, analysis of variance. So original value minus the mean. So original value is 7. The mean is 4.5. So we do 7 minus 4.5, which is 2.5. 2.5. Then we're going to square it, which is this button right. Where'd it go? Right there, where it says x squared. Click on that. The square of 2.5 is 6.25. 6.25. Just like that. So do that for all those, and then add them up. I'll do one more together with you. So we have the original value is 3. We subtract the average, which is 4.5, which gives us negative 1.5. Then we'll square that with our square button. Now it's 2.25. And you might have noticed that it went from a negative number to a positive number. Any number squared is going to become positive. A square is just the number times itself. A negative times a negative is a positive. But that doesn't mean that two wrongs make a right, because it's math. It's different from reality. Okay, so what I'll do here is I'm going to pause the video and I'll fill these in myself. So why don't you pause the video and then fill in the rest of these, and then when you play it again, you'll see what I put and you can see if you got it right. Okay, while it was paused, I filled in the rest of these, so take a look at the ones you did and see if you got the same thing. So 5 minus 4.5 was a half, and the square root of that would be 0.25 all the way down. So 6.25, 2.25, 2.25, 6.25, 0.25, 2.25. Okay, so now we want the sum of squares. So here's the squares, right? The squares. We want the sum of squares. So all that means we have to add all these up. That's pretty easy to do. So we're just going to go down this column here, 6.25. So I'm using the buttons on my keyboard now instead of click, 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 a little easier. Plus 2.25, plus 0.25, plus 6.25, plus 0.25, plus 2.25. All that added up, 17 point, that's not a 17, 17.5. Perfect. So all of this, this part of the equation right here becomes 17.25. So everything here, 17.5, like that. So now we take 17.5, divide by this, take the square root, and we're done. It's not that hard, right? It's pretty fun. So now take the number of values in the distribution and subtract by 1. So the number of values, as you recall, 1, 2, 3, 4, 5, 6. Okay. So we put 6 right here. And then we say 6 minus 1, so n minus 1, sample size minus 1, is 5. Don't have to use a calculator for that. So the standard deviation is a square root of 17.5. I'm just bringing this down. Divided by 5, which I got from right there. So n minus 1 is 5. All that nonsense is 17.5. So the standard deviation is a square root of 17.5 divided by 5. Okay, scroll down here. Let's see here. It's exactly the same thing right here. Just wrote it again. Okay, so let's divide this. So 17.5 divided by 5 is 3.5. Like that. The square root of 3.5. So where's our square root button? It is right here. Also called a radical. Is 1.87082 blah 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 blah. We're on to the hundreds place, which is where the 7 is. The next number is under 5. In fact, it's 0. So the square root is 1.8. I'm sorry. Well, this is a square root, but the standard deviation is 1.87. So a measure of variability, standard deviation of these 6 numbers is 1.87. Okay. So now it's your turn to try this on your own. So down here, it's exactly the same thing. We have a different set of 6 numbers. So you'll find the mean of those, right? And then put that value here, put these values here. Exactly the same thing. Find the difference, square it, sum of squares. Exactly the same process. I cut and pasted this template. So go through there, work all those out. When you finish all of it, you'll save it. So just right now it should be called standard deviation practice. So just do save as, and then upload that to Blackboard, and which is right Blackboard. So it'll be practice problems. So you'll click on practice problems, and then just attach it right here. Browse my computer, attach it, submit it, and that'll be for 15 points, participation points. Okay, so overview of the week one lecture. You had the readings. You took a look at all these PowerPoints. This is review. This is for your benefit. Then we had the lecture that hopefully you already went through. So there's the PowerPoint, and then I haven't uploaded it in my version yet, but you should see this in your version. You'll go through all of those, and then down here you already downloaded this. You filled it in. That was this right here. Saved it, uploaded that for points, and then the last thing is the quiz. So you click over here, and then the quiz is set up so you can see all of the questions at the same time. So there are, let's see here, there are 15 questions. Last one's a multiple choice. One of these involves finding the standard deviation. So right here, what is the standard deviation of the sample? So you work that out by hand like we did before. That question is worth more points. That's 4 points. And a lot of these, they're 1 points. They're 1 point. They're not really that hard to figure out. And you are completely welcome to go back and look at the book, look at the notes. We're going for mastery here, so take your time. It is not timed, and you can save your answers and then go back later if you need to. So take your time on that. Just remember that everything, and yeah, I'm not really taking it. I'm the teacher. Everything that is in here is due on day 4, so that's Thursday. Okay. At that point, you'll want to begin the lab portion of the class. If you're in the hybrid class, we'll do that together. And then if you are in the online class, you go ahead and head over there on your own, and I'll have videos walking you through that process as well. Hope you're enjoying the class so far, and it's not too confusing. And please email me if you need help with anything.